Over the past century, philosophy shifted away from what we might call everyday or traditional logic toward formal logic, meaning the use of symbols to represent reasoning instead of ordinary language. So instead of writing words like not or if-then, logicians use precise symbols that express the same relationships. It can look technical at first, but the goal is simple: to remove ambiguity and make the structure of arguments completely clear. As this symbolic approach developed, it gave rise to a variety of logical systems. You don't need to master all of them, but here's a quick sense of the landscape. Predicate logic, for example, expands basic logic by introducing quantifiers like all and some, which allows us to formalize statements such as all humans are mortal. It gives us the tools to talk systematically about objects and their properties. Other systems move in different directions. Fuzzy logic allows statements to be partly true rather than strictly true or false. Intuitionistic logic keeps the true or false framework, but requires that a statement be supported by a proof before it counts as true. These systems are generally divided into two broad families: classical and non-classical logic. Classical logic includes both propositional logic and classical predicate logic. It rests on a few central principles. One is the principle of bivalence, which says every statement is either true or false with no middle ground. Another is the law of the excluded middle, which says that for any statement, either it is true or its negation is true. For example, either it's raining or it's not raining. There is no third option. Over time, however, philosophers began to notice that this classical framework does not always handle certain cases smoothly, especially when we deal with vagueness, uncertainty, or specific issues in mathematics. That's where non-classical logics enter the picture. Intuitionistic logic questions whether we can declare a statement true or false without a proof. Fuzzy logic allows for degrees of truth, so something might be mostly true rather than entirely true or entirely false. Consider a simple everyday case. This person is tall. In classical logic, this has to be either true or false. But in reality, someone who is 179 centimeters might feel kind of tall, but not clearly tall or clearly not tall. Forcing a strict true or false answer can feel artificial here. This is where non-classical logics start to look appealing. In fuzzy logic, we can say something like, this person is tall, true to degree 0.6. So instead of forcing a sharp boundary, we allow for gradual truth, which fits better with vague concepts like tall, rich, or old.